Hey guys, I just wanted to quickly give you a little bit of a bonus content on vectorization. This is a topic that I think is very easy to miss when you're first starting out in Pandas, and I think there's a couple of great resources that do cover this in terms of introducing it in Pandas, but they're usually pretty hard to find or locked behind paywalls. So I want to make sure that you get to see this concept and have it kind of explained to you before you actually see it in this week's coming content. So what is this vectorization thing? In short, it's when the information that a variable represents an entire vector of data rather than just a scalar. And probably, unless you've taken a linear algebra class in the last 3 or 4 years, it may not necessarily be clear as what a vector is. So just covering that really quickly. We are accustomed to working with scalars in most of our everyday math. So a scalar is just some number. It can represent a magnitude, it can represent a scale, but it's a pretty just like plain old number, and we can represent that in Python pretty easily just using the actual number. But we can also represent groups of numbers representing a more higher ordered structure. So this vector, if you will, is something that we'll often see in a lot of math classes, especially again in linear algebra or in certain types of calculus courses. And we've actually worked with quite a few vectors in class already. In Python, we simply represent these as lists. So not something totally wild and out there, but definitely worth explaining that what this is. You'll also see things like matrices, where instead of having everything in one nice column, you can have multiple rows and columns. This can go up to 3 by 3 and n by m, so make them as big as you want. And we actually represent those in Python. We've touched on this a little bit as a list of lists as a data structure. So these different types of information are all representing higher order or more finely detailed variants of information. And of course, there's things that go beyond matrix. We'll talk about tensors in a few months once we actually get there. So just to give you an example of how we actually use these vectors in kind of a more mathy setting, you're probably accustomed to seeing this y equals mx plus b equation. Probably seen it back in Algebra 1 in middle school, used it a couple of 100,000 times throughout your entire life. This is where everyone always asks, when am I going to use this in my real life? Well, we're finally there. So y equals mx plus b is actually a really profound equation because we can use it in not only a scalar context, but also in these higher ordered contexts. So that m can actually be a vector and b can actually be a vector, and in fact x can be a vector as well. So once we start playing around with these different forms of this equation, we can start working with doing math in some pleasantly more simple ways for more higher ordered problems. So the real question is, why should you care right now? The important thing to understand is that Pandas is going to use vectorization to help clean up our code and write a lot of calculations faster. It does this by vectorizing some of these variables so that we don't have to write for loops, and that's a really important thing because we like clean code. So let's look at a couple of examples really quickly. First, we have these lists, and Pandas is actually going to create what we will refer to as series instead of just lists. But the important thing to see here is that we're creating my list. It's just a list of 3 items. And let's say that I wanted to add 3 to every one of those elements. Well, I'd have to loop over that list, printing off each one of those individual numbers added with 3. Pandas allows us to do something a little bit similar. We can actually import pandas as PD. You're going to be using this line religiously pretty much until the end of the class, but we can create a series from that list, which will allow us to print off the entire series plus 3. And what I want you to see here is this subtle shift that's happened. Number doesn't represent, or excuse me, number represents exactly one item in this list. And if I wanted to do an operation on my list, I would need to loop over each item in the list performing that operation. What vectorization has done for us, though, is enabled us to simply say, well, I want to take all the values in that series and add 3 to them. So the subtle shift that vectorization enables for us is the ability to create a variable that represents the entire group of items and do an operation on the entire group individually without having to necessarily write a for loop. And that's going to be extremely helpful when we start dealing with tabular data. To unpack yet another example, the dictionary has an analogous, somewhat analogous, not perfectly analogous, data structure in Pandas referred to as a data frame. So let's look at a dictionary really quickly. Let's say I've created this dictionary. It's got keys for the ID, name, and age, and values, which are lists for each one of those items. Well, that's another compound data structure. And I have a key and then a series of data, or rather a set of data, that sounds kind of like a table, right? It's got a column name at the very top, and then we've got values that go down each one of those rows, and we can see that in this data set that there are analogous values for each one of those rows. Let's say I wanted to take one of the columns out of that table and add 3 to all of the values that are in that column. I would need to, again, coming back to a for loop, loop over each age in my dictionary, selecting that age column, and then printing off this placeholder value for age plus 3. Well, Pandas lets us do something really cool. We essentially can create a data frame, which I'll represent here using df, and we can essentially say, I want to take that data frame, this data structure holding all of this same data as this dictionary, and I want to take the age column and add 3 to all the values in that age column. Again, these are analogous to one another. They're doing more or less the same thing. They're not 100% equal. There's some little ticky-tacky changes in here, but what I want you to understand is what vectorization is doing for us is making it so that we don't have to write this entire for loop in order to carry out an operation on every element within that particular set. Thank you guys very much, and I will see you soon.